Today we're announcing Omega, which is a manufacturable chipset for photonic quantum computing. So we're publishing in Nature data showing the performance of a complete set of components with which we can build very large-scale fault-tolerant optical quantum computers. All of those components existed a decade ago before we started the company, but back then we knew that we would need to integrate those components together, that we would need to move them into a high-volume, mature, commercial semiconductor manufacturing environment, and that we would need to climb a performance curve that at the time seemed borderline impossible. And it has been so encouraging and wonderful to see the team execute on those plans and bring us now to this position where we can build all of those components. They're performing beyond the state of the art, and we're building them at the highest level of maturity of semiconductor manufacturing that exists at global foundries in upstate New York. That really puts us in a position where we can now build, manufacture, and cool as many chips as we could ever dream of. We'll continue to improve the performance and yield of those components, but really the primary task now is about wiring those chips together into increasingly large systems. That work is already underway at our facility in the UK, where some of this testing was done, as well as at the Stanford Linear Accelerator here in California. And those intermediate systems will pave the way towards the much larger machines in Australia and Chicago, where we're breaking ground later this year. Quantum computing is a field where we hear a lot about breakthroughs, and I think it is maybe underappreciated that breakthroughs really are the beginning of the journey, not the end of the journey. And I'd argue that we really had our breakthroughs 10 or 20 years ago when we first showed photonic qubits and gates and put those photonic qubits on a chip. And since then, really we've been exclusively focused on maturity and scale and taking those devices out of the research lab into a commercial fab. And that was a really daunting prospect back then when we proposed these plans. And it's just been amazing to see how the team has stuck to the plan, has executed on these extremely aggressive roadmaps, and has become, as a result, inoculated against hard things. And that property of the team here at PsiQuantum is so inspiring to me and really gives me the confidence that we're going to pull this off.